start with rotation. So when we deal with rotations, when we rotate, we're always going to have two things that you're going to be told to use. You're going to be told a center that you're going to rotate about, and you're going to be told a degrees, like 90 degrees, 180 degrees, or 270 degrees. These are the specific ones we're going to use. So you're going to have two of these things, either that, or you're going to be given the rotation. You're going to be asked how many degrees you rotate by, or something like that, or where is the center you're rotating from. But this is what's you're going to see one of these two things, or two of these things, and you're going to use that information to help you perform this rotation. The reason we're rotating by these three specific amounts, we're only going to have three specific amounts we're rotating by. And the reason it's going to be these three is because they're sort of your quarters of a circle. So whenever we're rotating, we're always rotating in a circle. We're always going around. At 90 degrees, you've gone a quarter of your circle. At 180 degrees, you've gone half of your circle.
How do you know where to start in a circle?
In this example, I'm starting at this left side, but you'll start wherever where your position is on the map. So in this example at point A, you're starting right here, and you're rotating 90 degrees this way. On this example right here, I'm going to say I'm starting at this spot of my circle. If I rotate a quarter, I rotate 90 degrees. Half is 180. 3/4 is 270. Why don't you think we'll learn a rotation rule for 360?
Because then we're just going to end up in the same spot.
You're just going to end up on the same spot. You're just going to go all the way around a circle, and there's no reason to learn a rule for that. You're just going to stay the same. So these will be the three specific locations we're going to learn about. It is possible to figure out where it would be at. It's like 60 degrees, but those are harder to work with. Those are harder to remember. And so these will be the three that I want you to have memorized. We won't rotate together. Whenever we're talking about rotation, we're also going to be going counterclockwise. So we'll always be rotating counterclockwise. If it doesn't say, assume it's counterclockwise. If for whatever reason you are rotating clockwise, say it says rotate this shape 90 degrees clockwise, what rule should you use? Which would be 270. So if I told you to rotate 90 degrees clockwise, just remember 90 degrees clockwise is the same as 270 degrees counterclockwise. So that's a quick thing you can do. So you only need to have these three memorized, and that should work for really any rotation that's of 90, 180, or 270.
So if they tell us to go clockwise, we start off with that and what?
Okay, so those are the three we're going to talk about today. First one we need to talk about. And once again, our center we're going to use for these ones are always going to be at the origin. So we're always going to start at 0, 0. And we'll talk about what happens when you change your center later. If you say your center is way up here or down here. But for right now, just assume your center is at the origin. Okay, so we have point A. Point A was rotated 90 degrees. Where did A start? What's the location A starts at? 3, 2. Where does A prime end at?
-2, 3.
-2, 3. So we started at 3, 2, ended up at -2, 3. What do you notice happened here?
It's switched.
It switched. Okay, so we started at 3, 2, transformed and rotated, and at -2, 3. So if we notice, our coordinates switched places. Our x became our y became our x. What else happened?
Here, it became negative.
My 2 became a -2. My y turned into a negative. So kind of like a reciprocal, except rather than flipping the fraction, you're just sort of switching locations. So as a generic representation of this, if I have points A, B, where A is just some point in my x direction, B is some point in my y direction, so like 1, 2, or 3, 5, or wherever I'm located. If I were to rotate 90 degrees counterclockwise, I take those two coordinates, I switch them, and then my first coordinate becomes negative.
Is that what's like that?
It will always be like this for 90 degrees. Take your coordinates, switch them, B becomes negative. So that's your first rule to remember. So we can practice with this. go to the next one. We're rotating point 90 degrees, or B, 90 degrees counterclockwise about our origin. So once again, we're starting from our origin. We're going 90 degrees counterclockwise. All we need to do is find the coordinates of B. So where does B start?
4, 1.
4, 1. So I'm starting at 4, 1. In order to transform this, I just need to switch them. So 1, 4. And then 1
Negative 1, 4.
would now become negative. Yes, so negative 1, 4. So B is then going to end up at negative 1, 4. So we'll end up all the way up here. All right, Amanda, because you just joined us, I'm going to do a quick review. So we're talking about rotations. When we talk about rotations, we're always going to have a center. Right now, our center is the origin, and we're going to rotate by a specific amount. Right now, we're dealing with 90 degrees. Anytime you're dealing with 90 degrees, you're going to take the coordinates of your point, you're going to flip them, and make the first one negative. So AB becomes negative BA. Good. Yes, Colton, do you have a question?
How do we know to take this circle out from the center?
I'm sorry?
How far do, well, how do we know how far to take out the circle from the center?
So depending on how far your point is from that center will be the radius of your circle. And so depending on where your center is located will depend on how much you're going to be spinning around. But right now we're just dealing with the origin. So we can do the same thing with ABC, triangle ABC. My point A, that is at located 1, negative 1. If I were to transform this, I switch them and become negative 1, 1. But that negative 1 needs to change signs because it's my first one. So that's going to become 1, 1. 1, 1 from my center is over 1, up 1. That's point A. Do the same thing with B. B is currently located at 3, negative 1. 3, negative 2, I'm sorry. 3, negative 2. If I transform that, I switch them, it becomes negative 2, 3. But that negative 2 needs to change. It needs to change sign, so it's going to become a positive 2, 3. So from my center, I go positive 2, up 3. And that is B. You can do the last thing again, finish C on your own, see if you can find that location on where C B takes off this information. And you might also be able to eyeball it as well. Here. Get that. Take a quick moment. Get that last one. So we're at 1, negative 3. We switch that B should become 3, positive, negative, positive 1. That would be C prime. So this is your triangle. And if you're really good visually, and you can see these visually, and you can know exactly, or you know where they're going to end up, you might be able to only move. You might only have to move one part of your triangle, and then you see, oh, I know B's going to be up here, C's going to be up here, just by I can visualize it, and that's awesome. If not, you might be a person who has to do every single point and calculate every single point, and that's okay. Just take your time, work through it. If not, you might go over to do some shortcuts. But don't force yourself to try to have to visualize the rest of it. If you need to calculate all the points, calculate all the points. Another thing to look at is when we talk about going from 90 to 180 to 270, we're rotating about a quarter of your way around the circle. So if you look, you're rotating only one quadrant for 90 degrees. So we started in the fourth quadrant, we ended in the first quadrant. If we're rotating 180, we're going to rotate 2 quadrants. If we're rotating 270, you're going to rotate 3 quadrants. So that's another way to check your work. If you're ending, if you know you should end up in the first quadrant, but you're not, and for whatever reason you're in the third quadrant, maybe you did the wrong rule. Maybe you messed up with a problem. So that's a good way to be able to check your work based off your information. Are we okay with 90 degrees at the moment? All right. Next one we have 180 degrees. So once again, our point A, just like from before, is at 3, 2. If we look, we rotated 3, 2, 180 degrees. Where did 3, 2 end up?
Negative 3, negative 2.
-3, -2. Okay. How has this one changed?
Everything becomes the signs which is right.
So they stay in the same spot. So 3 stays in the first part, 2 stays in the second part, but they change signs. So if I had AB, how this is going to change is this is going to become negative A, negative B. So I don't switch anything on this one like I did with 90 degrees, but I just make both signs negative. And when I say make both signs negative, what I really mean is I'm switching the sign. Because if this was a negative 1, it would become a positive 1. If this was a negative 2, it would become a positive 2. I don't automatically make everything negative. I'm just sort of adding another negative on there, so switching the sign. So just switch whatever sign starts at. So for example, over here, we have this point C, which I think should be on here next, should be on the top of the next page. C from our center is currently located at 1, 2. And we are to rotate 180 degrees, we just need to change that to negative 1, negative 2. So we don't need to switch anything, just change those signs. So I go from negative 1 to negative 2, and that's my C prime. So I think 180 degrees personally is the easiest rule to remember, just because you're not changing anything besides signs. 270 and 90 are a little bit harder if you have to switch the things around. But take a moment, see if you can finish that last one on your own. Okay, so assume you were able to do that one. So you should have had your triangle end up down here. So this should be your A prime, this should be your C prime, this should be B prime, your triangle on that bottom left corner. Correct? Okay, awesome. All right, last rule we're going to talk about for rotation. This one is going to be at 270 degrees. So if we start at 3, 2 again, where do we end up?
2, 3.
To negative 3, because we're going to be down.
So we just switch them like we would 90 degrees?
So we're going to switch them like we do with 90 degrees. So it'll become BA. But what's different?
It's going down.
The negatives on the, yeah.
The A will be negative this time. So with 90 degrees, you switch them, but the B became negative. That first number becomes negative. With 270, you switch them, the second number becomes negative. So the way I remember this is 90 comes first if I do a rotation. 270 comes last. So on my first one, I make my first one negative. 90 is the first, so the first letter becomes negative. Your first space. 270 is last, so that last spot becomes negative. That might help you remember them, because other than that, they're pretty similar. So let's look at an example of this. So we have D. D is currently at 4, 2. If I rotate D about my center, I switch their locations, so it becomes 2, 4, but then my last spot needs to change signs.
Negative.
So negative 4. So I go 2, negative 4, and this puts me down in that fourth quadrant. That is D prime. Once again, I can know I went in the right way because I started out with quadrant 1 and I moved 3 quadrants to end in the fourth.
So with 270, there is 3 quadrants.
You always move 3 quadrants. As long as you're rotating about the center of the origin, or the origin is your center, you should move quadrants. If your center is a little off, you might not move out of the quadrants all the way, but you should still be able to help visualize it. All right, take a moment, see if you can get this last one, DE. See if you can rotate that 270. Okay, so if you were able to get this, you should have ended up with a horizontal line in the first quadrant. So it should be D, E, in that first quadrant. Okay. All right. So those were our 3 rules that we talked about. So we had 90 degrees, 180 degrees, 270. So for 90 degrees, what was our rule? What did we end up with? We start at AB.
Negative B.
Negative BA. Good. What about 180 degrees? Negative A, negative B. 180 degrees, that's the one where you keep them the same, you just make everything negative. Last one, what's 270?
No.
It's going to be B, negative A. Okay. So those are our 3 rules to remember. So it will take a little bit of time just to sort of be able to practice with them, be able to memorize them, to sort of keep, be able to recall what rule is which and how to rotate specifically. But the more you practice with it, the easier. And that's what tomorrow will really be a big practice with this. All right. So we talked about what happens if our origin is at the, or if our center is at the origin, but sometimes it isn't. Sometimes our center is completely off the origin. And so this is where rotation gets a little bit harder. And this is where some students get tripped up because they're counting the wrong thing or something. So when you're rotating, when your center is not on the origin, you need to basically forget everything else about this axis. So both of these, this y and this x-axis, just pretend they're not there. Just forget it. We're going to be worrying about the center. The center is the thing you're going to always refer back to. So we're going to pretend the center is my new axis, my new origin. From here, I need to figure out what the locations of these points are. So from A, if I go over and count, this is 1, 2, 3 spaces to my left, 0 spaces higher. So if I were to count that as an ordered pair, that would be 3, -3, 0. I went 3 spaces to my left of my x, 0 spaces higher. Back to your left. I'm going to rotate this point. So let's say we're doing 90 degrees. So 90 degrees, I flip them, make the first one change sign. So I flip it, it becomes 0, -3. I change the sign of my 0, but that's -0, which isn't a thing, so we'll leave that. So that becomes, I will now use this point as my new ordered pair for my A prime. But the thing is, I'm not going to count from my original origin. I'm going to count from my center. So from my center, I'm going 0 my x, -3 my y. So my A prime will end up down here. I assume you didn't go from the center, didn't come from the center. So if you don't come from the center, you're going to be spinning all the way around, and you're going to be spinning around your origin. So always remember to count back to that center. Otherwise, it'll throw you off. You'll be completely out of your origin. Let's look at B. Get out of the way. So B, from our center, always come from our center, is -1, -2. We'll rotate this. We flip them, so it becomes -2, -1. That first space needs to change signs. That becomes a +2. +2, -1. So from my center, I go +2, -1. This is my new location for B prime. One more. I have C. C from my center is left 3, down 2. If I write that as -3, -2. I then rotate this. My 90 degrees, it gives me -2, -3. Change the first value. +2, -3. Back to my center. Always go back to that center. +2, -3. This is C prime. And this is my new rotated triangle. So we're spinning down and around. Keep spinning around. So we're no longer spinning around that origin, we're spinning around that center. It is harder when you have to lose. Some students last year, they kept counting by the axes, and they would keep tripping themselves up, or they'd get this value correct, and then they'd go plot it on the axis. So what some students started to do was they would draw their own new XY axis. So they would completely forget about the other ones, and they would just focus on this one. And so if that helps you, do that. That way you don't get confused about where you're rotating and things like that. And that also helps you see the coordinates that you're turning as well. So that could be a good strategy to try. Yes, Cole?
Can the center would be not on the perfect?
Like not on one of these crosses, say right here.
Yeah.
It's possible, but that's a very tricky question or very tricky spot to go from. You would have to count half and 1 and 2 and things like that. So I would never throw anything like that, and I hope your state test doesn't throw anything like that. That would be a very terrible move to do. So you shouldn't see anything that's not on a location like that without them. So take a moment, see if you can do the last one. See if you can do rotate 180 degrees about your center. Remember, always count back from that center. Always go back to that center. Okay, so if we did this, we should end up something with like B here, and then A should be down here.
It's the middle. Yeah, so
Oh, whatever you're playing with at the moment? I thought you were playing with a problem. Like that. Alright. Are we okay with rotations? We feel good with this? So those are our 3 rules with rotation. We do have one other thing that we want to talk about. We have one more transformation we're going to get to today, and it's called dilation. So dilation is a little bit different because you're changing sizes of your shape, and it's sort of turning and sometimes changing location. But it becomes easier as soon as you learn how to do rotation. So now that we know how to do rotation and we know how to count and go from the center, this will be much easier. And the reason is because dilation, just like rotation, will give you 2 things. First thing, it'll give you the center. Center, if I can spell center. It'll give you a center. So in this case, your center sometimes is at the origin, but in this case, your center is like at 1, 1 for this example. So it'll give you a center. Second thing it'll give you is called a scale factor. So the scale factor, this is the ratio of how much you're increasing by. How much are you growing in size? Are you growing by a scale factor of 2? Are you doubling in size? Are you shrinking by half? Are you multiplying by 1/2? Are you only going by a third? Are you going by 3 times the size? And so the scale factor is something that will help us determine how large are we growing or how large are we shrinking. And once again, we're going to use this center as a sort of base of operations, just like you did with rotations. And so, for example, we have this little triangle here, this little red triangle, and we see that from our center, it's up to over 3. After multiplying it by whatever scale factor they used, it turned into up 4 over 6. What do you think the scale factor is based off that information? What?
Times 2.
2, good. We're doubling. We're multiplying times 2, so that would be your scale factor. So that might be a problem you might see is, based off this dilation, what scale factor do you notice? But notice they're always counting from the center. They're not counting from the origin. They're counting from that center location. And that will be important to remember. So, for an example, a problem we might see is something like this. So your center, we're told, is the origin. To make it easy on us, to give us the origin. We're told our scale factor is 3. So what we're going to do is from my center, I'm going to find the location of C. So C is currently at -1, 1. That's my ordered pair for C from my center. I'm going to take that ordered pair. I'm going to multiply it by my scale factor. So my scale factor is 3. -1 times 3. -3. I can draw. Do this to me. 1 times 3 is 3. So -3, 3 would be the new location of my C. So I'll go from my center again, over 3, up 3. This is C prime. Do the same thing for D. D is currently located at -3, 2. Stop. 3, 2. Multiply that by 3. This gives me -3 times 3 is -9. 3 times 2 is 6. So -9, 6. From my center, over 9, up 6. D should end up here. And that is DC. If I notice, the length of DC is also 3 times longer as I started. And that's because our scale factor was a factor of 3. Okay with this? Take a moment, see if you can do the triangle. See if you can find where should your scale, or what's your scale factor, where's your center, where should each of those points end up for that second triangle.
Does the center not really matter in this one?
Okay, so we should have ended up with this much larger triangle that sort of overlaps on top of your smaller triangle. But each of those points are just extended out farther. Final thing, what if your center isn't at the origin? So just like we had with rotation, sometimes your center isn't always at the origin. That's okay, we know how to deal with it. We're just going to count, just like what we did with the rotations, we're just going to be counting those ones. So rather than looking at this as 6, 3, I'm going to count from my center, I'm going to go 1, 2, 3, 4, up 2. So point A is no longer 6, 3, it is now 4, 2. And if you're one of those students who needs to draw the axes in there to help you, go for it.
Wait, it wouldn't be -4, -2.
So I'm going in the positive direction for both of them. So I'm going to the right.
Wait, you wouldn't start at A?
I started at my center.
Oh.
So I counted +4 for my center and up 2 for my center. So yeah, always go back to that center as your starting point. Always start from that. And then from here, I need to multiply my scale factor, which I'm told is 1/2. So I multiply by 1/2. 1/2 times 4, or half of 4, is 2. 1/2 times 2, or half of 2, is 1. So 2, 1 is my new location. But rather than going from my original axes, I need to go from my center. So I'm going over 2, up 1. That is my new location for A prime. I can keep going with this. I'm going to do D next. Okay. So D is over 8, up 2. So, no. D is over 8, up 2. Multiply that by 1/2. That gives me half of 8 is 4, half of 2 is 1. So for my center, over 4, up 1. 1, 2, 3, 4. Oh, I counted wrong. This isn't 8, is it? That's 6. And that's the mistake you're going to make. For a big mistake. That's 6, 2, which makes this 3, 2. 3, 1. Okay, so 3, 1 should be right here. I'm struggling today. Let's see. And from here, you might already be able to find what your next point is, and your point after that. B should be up here. C should be up here. Or using your knowledge of squares and what they should look like. So if you notice, your square is half of the size. All your side lengths are half of what they originally were. So originally your side lengths were 2, but now they're all 1 because we shrunk it by 1/2. So anytime you have a scale factor of less than 1, it's always going to shrink. Anytime you have a scale factor of greater than 1, it's going to grow. Yeah, you might see something 1/4. You might have it'll probably be a larger shape to start with, to shrink by 1/4. But it's possible.
So like anytime the fraction.
Mm-hmm. Yeah. Other situation though. What if your scale factor is a negative? What do you think is going to happen here? So it's going to get big, but it's also going to sort of invert itself. The negative is going to like flip it around. So it changes a little. So let's look at this. So we have our center. From our center to D, it's -2. We're going -2 in the x, and then up 1. So -2, 1. I'm going to multiply that again by my scale factor of -2. -2 times -2 gives me a +4. -2 times 1 gives me a -2. So -2 or 4, -2 is now my new location for D prime. So from my center, I'm going 4 in the positive direction and -2. So D prime is all the way down here. It doesn't look like where it should be. But let's keep going and see why. E from my center is, let's see, left 2, down 2. So that's -2, -2. Times -2 will give me a +4, +4. -2 times -2 is +4. So +4, +4. E is going to end up all the way up here.
What? Why are you doing that? I'm confused.
What are you confused about?
My B ended up over there, so I did 4, -2. And then why did you put your A I have 1, 2.
So remember, we're always going back to that center. So from my center,
Oh, you're right.
I'm 1, 2, 3, 4, down 2. So
I was literally like,
that's the biggest mistake students always have. Is they always go back to the x equal or the x and y axis when they should always be thinking. The last part we have is f. If we look at f, it is, let's see, from our center it's 1, 2, 3, 4, -4, and then it's down to the -4, 2. Multiply that by -2. Especially we end up with -2 times 4 gives me +8. -2 times -2 gives me +4. So from my center, always go back to that center, I go +8, +4, and that should be up here. And so if we look, our triangle got inverted. It got flipped upside down along with growing in size. So whenever you have the negative scale factor, it sort of messes things up a little bit, but don't worry, your triangle's still fine. Any final questions?